Hello, everybody. This is the PHET circuit construction simulation. And what I'm going to get you to do today is build circuits and analyze them and see if you can figure out the relationship between the three concepts that we're going to be studying: current, voltage, and resistance. Now, this is fantastic. We can just bring in wires, make them as long as you want. You can do this. You can show the values. That's going to become relevant later. And so I'm going to stick a battery in here. I'm going to turn it around because I want the black end is the negative end. That's where all of the electrons would be. I'm going to put that here. And over here we've got another wire. And I like to have everything at right angles. That's where you're going to see circuits constructed in textbooks with everything in straight lines and right angles. It's just easier to look at. I mean, obviously in the real world, the wires don't look like that. They can, they go in all kinds of crazy directions. But this is just a lot nicer for analysis. So we'll go down here. And starting off, like what I want you to do is to make a series circuit. So what I'm putting in here now, the V stands for voltage. The ohms, that's resistance. And so let's put another wire down here, and you can just make this whatever length you want. Put in another resistor, and then another wire. Up this way. Oops. Bend that. Put in another resistor. So it looks nice and pretty. This is the kind of thing that you would see in a textbook. Like so, and now we've got our current flowing. The nice thing about this, we can choose the kind of the textbook look where everything is represented abstractly. This is what a battery looks like. The negative end is the short stick, and the positive end is the long stick. And in a battery, let's go back here again. I mean, what's happening is there's some kind of chemical reaction taking place inside this battery that pumps electrons from what would be the positive end to the negative end here. So you would have, let's just break this circuit for a second. So what's happening in this battery is there's a chemical reaction that's pushing electrons down into the negative end of the battery, stripping them from the positive end and pushing them down this way. Once it gets to a certain level, that reaction will stop because there will be so many electrons built up down here that the chemical reaction can't continue. So the battery will just be in a kind of a state of stasis. But as soon as you allow a circuit to flow, those excess electrons will enter a copper wire and they will travel around and they will enter into the positive end. And that allows the chemical reactions inside the battery to continue. And as long as there's enough material inside the battery to continue chemical reactions, that circuit is going to continue to flow. And again, we can chop it off, and the battery it will just go into a holding pattern where there is an excess of electrons here, a dearth of electrons here, and now it's ready. It's ready to cause more current to flow. But what I want you to do is change these values. You can change them to whatever you want. You can change this to whatever you want. You can put in whatever voltage you want. You can change the ohms to whatever you want. So these are measures of resistance, and that can be whatever you want, like this. And now you can use your voltmeter to put these probes on either side of the battery, on either side of your resistors, and you can check the voltage of all of the elements in your circuit. I can move this over like this. You can also take this ammeter and place it down on top of the wire, and it will tell you what current is flowing in the wire. So you can check the circuit, and I mean, really, what I'm curious to know if you can do is construct a circuit like this and figure out the relationship between voltage, resistance, and current for a series circuit. And draw up some set of rules, like in by yourself or in groups of two. Draw up a set of rules which kind of govern the way that electricity behaves in a series circuit. That's what we have here. We call this a series circuit because every electron has to flow through every resistor. There's only one path. When we get to the parallel circuits, it means that there are alternate paths that electrons can take. There are detours, right? There's alternate routes you can take. But in this case, in a series circuit, there are no alternate routes, and this is your only choice. So build yourself a series circuit like this. You can put in more resistors if you want. I put in 3 here just because it completes the square, but you can put in more. And the battery, you can make whatever voltage you like. The resistors, you can make whatever values you like. And then measure the voltages, measure the current, and come up with general principles that relate the current, voltage, and resistance in a series circuit.